Hi, my name's Chris Eliasmith. I'm co-CEO of Applied Brain Research, or ABR, a deep tech startup out of the University of Waterloo. We build low-power AI. So we're intimately familiar with the challenges of deploying AI to hardware. We know what it's like to try and eke out every ounce of performance. In fact, we've become experts at maximizing performance for less power. We've built many such systems for ourselves and our clients, several of which are Fortune 500 companies, and we provide a platform to allow others to do the same. That platform is called Nengo. It's been widely used for about 5 years now, and it allows you to write a single neural application and then run it on many different kinds of hardware, such as CPUs, GPUs, and, unique to Nengo, a variety of neuromorphic hardware platforms, including Loihi and Spinnaker. Nengo provides everything you'd expect from a deep learning environment, plus it adds a visual user interface, a focus on dynamic and low power techniques, and an expanding library of pre-built and customizable networks. Nengo's been used to build everything from record-setting speech and vision applications on Intel's Loihi neuromorphic chip to the world's largest functional brain model. But Nengo's evolving, and that's what I'm focusing on today. We're now using Nengo to target all neural hardware accelerators, everything people use to run AI efficiently. That is, we're helping users put the best solutions to their AI problem on the best available hardware. Why are we extending Nengo in this way? Because programming edge hardware is difficult. We don't just mean that you have to know a lot about AI and about hardware and about software environments. We mean that when it comes to hardware, you have to make critical business decisions of what hardware to use in an ecosystem that is incredibly fragmented. As you can see from the list on the right here, there are a lot of edge AI hardware vendors, which I suppose is a great reason for a conference. This diversity is great from the perspective of having choices, but it's enormously challenging from the perspective of picking the best hardware to use with your particular application. For each device you consider, you have to figure out a tool flow, set up a dev environment, optimize for that specific hardware, and then try to gather and compare performance metrics across all the hardware. Worse yet, the list is changing all the time. And at the same time, of course, the edge AI space is obviously a huge opportunity. EE Times estimates a greater than 50% CAGR from now to 2024. So it's no wonder there are so many different offerings. So how is ABR going to help? Well, we're leveraging our experience with Nengo to fill this need. Nengo already runs the same model on different hardware. So now we're putting the same option in the cloud to give users the ability to optimize for a wide range of accelerators that you can currently buy and know exactly what they'll get out of the hardware when it comes to deployment. Crucially, this will enable that one thing every business wants: data-driven design decisions. And this is especially critical when picking the right hardware for your application, because it can be very difficult to change hardware later on. So this is what ABR is focused on: making it easy to pick the best edge hardware for your AI application using NengoCloud. But there's more to ABR. You might remember at the beginning that I also mentioned ABR is a deep tech company. And you might be thinking, this is just a cloud platform. Anyone with a good AI software team could probably do this. But with ABR, that deep tech expertise is integrated into the cloud offering. Let me introduce you to a new class of neural network. Many of you know that if you're solving an AI problem that's processing a time series, anything like network monitoring, video, speech, and so on, you're probably going to use an LSTM. And for this reason, the LSTM has been called out by Bloomberg as the most commercially important AI achievement. And on the top right, you can see ABR's patented LMU, or Legendre Memory Unit. The LMU massively outperforms the LSTM. In fact, the LMU is unique in the world of recurrent neural networks for being derived from first principles to be optimal at compressing information over time. This isn't yet another variant on the LSTM or GRU, and it shows. As we're demonstrating with this graph, the LMU is 1,000,000 times more accurate at compressing 10,000 times more data than an LSTM. And best of all, for low power applications, this improvement is available while using 82 times fewer parameters. That is 41,000 for the LSTM and only 500 for the LMU. So of course, we're going to make sure the LMU is available in the NengoCloud. And it will be unique to ABR. But how are we going to make this advantage really obvious for our users? And we're going to do this by picking a specific but large first vertical. For us, that is automatic speech recognition. This market represents a clear, strong commercial opportunity. There was over 32 billion of wearable sales in 2019 alone, and over 1.5 billion smartphones are sold every year. And even as an established market, Grandview Research estimates it has a CAGR of over 17% from now to 2025. It's also a time-varying application, which is perfect for the LMU. So let's see what happens when we apply the LMU to automatic speech recognition. As we can see on this graph, which is focusing on keyword spotting, the LMU is outperforming state-of-the-art models across a wide range. These results were all published by their respective companies this summer. You can see that the LMU is beating both Google's best models and those from startup Darwin AI in terms of accuracy and model size. And crushing down the model size means that we can run the model very efficiently on commodity or special purpose hardware. The LMU, in short, is giving an unprecedented accuracy for every size of model. So let's look at some of these benefits running on hardware. So here we're showing somewhat older results, but running an LMU on an ARM Cortex-M4. And we're comparing it to ARM's own optimized models. Our even newer models that were on the previous slide would actually just increase this accuracy. So as you can see from this table on the left, the LMU keyword spotting system is 10 times faster. So this would give a similar reduction in power usage or let you run 10 times more for the same power. On the right, we're showing what happens as we scale the LMU up towards full speech applications. Our comparison in this case is to the optimized LSTM model, which is used in full speech systems in several large companies. As can be seen, the LMU's accuracy is similar, but with a third the number of parameters. And as a result, if we just run this on a standard GPU, we get a 40% reduction in power usage. And this is an advantage that we expect to be amplified on more specialized hardware. So this is the beginning of ABR's solution to the problem of the fragmented hardware space. The steps in our low-effort hardware deployment are pretty straightforward. Number one, you use the NengoCloud to build and test solutions for your problem, and we're starting with a focus on speech recognition. Number two, you build the best solution with either standard networks, or you can use our novel ones if you want. Number three, you use our hardware-aware training to optimize your solution for specific hardware and determine what the best solution is without having to buy or fiddle with any hardware yourself. And finally, you compile your final network and deploy it. So this evolution of the Nengo ecosystem also expands our opportunities to generate revenue. For instance, we're introducing tiered pricing to give access to more and more hardware targets. We'll keep desktop CPUs and GPUs free. In addition, we'll charge for pre-made solutions to a variety of problems and data types. As I mentioned, we're starting with speech applications, but ABR has built models ranging from cybersecurity to video analytics to drone controllers. As well, users expect to pay for compute time they use when training AI models. And finally, for more advanced customers, we can include their specific hardware of interest in our cloud, and we can work with them to provide turnkey services or a la carte support for particular applications. And finally, we intend to sell licenses for the ABR unique IP like the LMU. So you won't be surprised to hear that we're currently in the scaling stage of our commercial development. Right now, we're profitable and we're growing, and we haven't taken any investment, but we're looking to grow quickly. And we want to leverage our current infrastructure and expertise to build this powerful, easy to use, and effective platform for edge AI real-world deployment. Right now, we're building more backends for a variety of the most popular AI hardware, and we're continuing to work with current customers to develop licensable products. And of course, we're pushing out NengoCloud. Our team at ABR is currently about 20 in size. 10 of those are PhDs, and they have expertise across the spectrum of AI applications and hardware. We're dedicated to making NengoCloud the one-stop shop for testing out and deploying to the fantastic new array of edge AI hardware, much of which has been on display at this conference, no doubt. Thanks for your time.